Lecture we're going to discuss about the how to find the inverse Z transform. Now there is a normal procedure, so generally we don't use that procedure. So the normal procedure is we will find the inverse Z transform from the inverse DTFT, that is discrete time Fourier transform. We know that from the discrete time Fourier transform, this x of n is equal to 1 by 2 pi integration over one period into x of e power j omega into e power j omega n d omega. So this is the discrete time inverse discrete time Fourier transform. This is inverse discrete time Fourier transform. Now what is a Z transform? Inverse Z transform is nothing but, so from the discrete time Fourier transform we can have like this: x of n into r power minus n. Yes or no? The Z transform is nothing but Fourier transform of the x of n into r power minus n that we have seen in the lecture 1. That is part 1 in the Z transform. So it's equal to, so from the discrete time Fourier transform it will become 1 by 2 pi integration of over one period. So this will become, in place of x of e power j omega, we will get x of r into e power j omega into e power j omega n t omega. Now here we don't require this r power minus n because we know that x of n, what is the Z transform? X of z or x of r into e power j omega. So only we need x of n. So if I multiply with r power n, so what we'll get? X of n is equal to, so 1 by 2 pi. If I multiply with r power n, so here you will get r power n. So there is 2 pi x of e power j omega into, so r into e power j omega whole power n we will get. This is d omega. Why? So if I multiply with r power n, so r power n into r power minus 1 we will get r power 0 as 1. But here we need to multiply with r power n. So in this e power j omega n we are having n, so that will become r power n into e power j omega power n. Now if I want to convert into z domain, so z is equal to, we know that r into e power j omega. Now with respect to, if I differentiate, so what we'll get? dz is equal to r into, with respect to e power x means e power x only, into with respect to omega means j into d omega, right? So this is the, so what we need? d omega. So d omega is equal to dz by r into e power j omega into j. So what is r into e power j omega? Is nothing but j. So this will become dz by j into z power minus 1, right? So this is d omega. Now if we substitute, so we will get it as a z transform. Now, so this x of n will become 1 by 2 pi j, because this is the j here, integration. Now this integration over one period will become the contour integration, because we are converting into the complex variable which is z. So contour integration around a circle, and this x of e power j omega so can be written by, say I forgot to write r here, so x of r into e power j omega is nothing but x of z into z power n into, so this is dz into z power minus 1, so z power minus 1 into dz. So if I write finally, this is 1 by 2 pi j in the contour integration x of z into z to the power n minus 1 dz. This is the inverse Z transform formula, but we never use this formula to find the inverse Z transform. But we should know what is the equation for the inverse Z transform, right? So 1 by 2 pi j, this will be contour integration x of z into z power n minus 1 into dz. So this is the normal procedure, but the alternate one is we will use generally the partial fraction expansion method, right? The partial fraction expansion method. So what is this? Is generally this x of z can be replaced by, so whatever the x of z will be given, so that can be written in form of expansion, partial expansion. So that is I is equal to 1 to some variable m and the constants a by 1 minus a small I into z inverse. We need to bring the x of z in this form, right? So for I is equal to 1, this will become a1 by 1 minus a1 z inverse plus a2 by 1 minus a2 z inverse 2 and so on. So whatever the how many combinations we will get, so we'll write in this form. Maybe one pole, if it is one pole only we'll get one fraction, two poles means two fractions and so on. So the expansion will get like this. Now for each individual ROCs, for each individual ROC1, ROC2, so we'll get the inverse Z transform. That is, suppose we will take x1 of n plus x2 of n and so on, right? So that is the inverse Z transform. So this method is very simple, right? The partial fraction expansion method. Now how to get this x1 of n and x2 of n depending on this ROC1 and ROC2. So if so this is a1, right? If mod z is greater than a1, so this x1 of n in the form of a1 power n u of n. Now similarly, suppose if a2, suppose mod z is less than a2, so this is some example I am taking. So mod z is less than a2, so what is x2 of n will become minus of a2 power n u of minus n minus 1. This is the two forms depending on the individual ROCs, right? So if this ROC is suppose less than a1, so this x1 of n will be in the form. If this is greater than, this will be in this form. So that we need to find depending on the given problem, right? Now one more approach is there. Apart from this partial fraction expansion method, there is a power series expansion method. So what it indicates is, suppose x of h z is given as 1 by 1 minus a into z inverse. I am taking directly example, and the ROC is given as mod z is greater than a. Now this can be, we can expand is power series, right? How this will be 1 minus a z inverse power inverse, right? It is looking like 1 minus x inverse, right? And this x is suppose less than 1, right? Then what is the expansion? 1 plus x square plus x cube and so on, right? So this is the power series expansion. So using this expansion method also we can find the inverse Z transform. Remember, mod z is greater than a means this a into z inverse is less than 1. So that's why we'll get the expansion series. So how it will become? So 1 plus x, that is a into z inverse, plus a into z inverse whole square. So a square z inverse 2 plus a cube z inverse 3 and so on. This is the x of z, right? Now once we know this one, so we can easily find the inverse z transform. How? So we know that for delta n, what is the z transform is 1. If this is delta n minus 1, what is the z transform we got in the previous lecture? This was z inverse. Similarly, delta n minus 2. So what is z transform? Minus 2 and so on. So if I take the inverse z transform here, so what we will get? X of n is equal to delta n plus a into delta n minus 1 plus a square into delta n minus 2 and so on. But this is the not a finite sequence, so it's an infinite sequence we will get, right? So that is the power series expansion method. Now what happens when this is mod z is less than a? That is one more method approach generally. So that series expansion will become like this. If mod z is less than a, so same expansion, that is x of z is equal to 1 by 1 minus a z inverse, will become like this. So we have to divide with minus a into z inverse plus 1 like this. Remember, so this expansion is also can be written like this in opposite way. So 1 minus a into z inverse, if I divide with this one, so 1 minus a into z inverse minus plus, so a z inverse. To cancel this one, we should have a z inverse minus a square z inverse 2 and so on, right? So same we can get this one, but it's not necessary to divide again. So just we will get the expansion. But once it is module is less than a, we cannot apply the same power series method. So we'll have the opposite, that is minus a into z inverse plus 1. Now to cancel this one, what we need? Minus a inverse z. So z into z inverse 1, a inverse into a, again 1, minus minus plus 1 minus a inverse z. So it will be cancelled plus, so a inverse z. Again to cancel this one, what is we need to multiply? Minus a, this is inverse, right? So we'll get what? A inverse 2 on this one. So z inverse is there, we need z. So what we need to do? Multiply with z square. So we'll get a inverse z minus a inverse 2 z square. Again these two will be cancelled. A inverse 2 z square minus a power minus 3 and z power 3. So 3 into minus 1, 2. So a inverse 2 z square minus a inverse 3 z cube and so on. Right? So this will be not finite, it will be infinite sequence. So what is the x of z now? It is minus a inverse z minus a inverse 2 z square minus a inverse 3 z cube and so on. Now if I take the inverse z transform, so x of n will become minus, so z means z power 1, so it will become delta n plus 1 by a. Yes or no? So minus 1 by a square delta n plus 2 minus 1 by a cube delta n plus 3 and so on. Now in the GATE exam they may give the inverse z transform as sometimes like this, or sometimes in the form of like this, right? So maybe a power n or 1 by 2 power n u of n, etc. So depending on the answer also we should apply the either one of this method, either power series expansion method or the partial fraction expansion method, right? Now we will solve this question. Now x of z is given like this, 1 minus 1 by 3 z inverse by 1 minus z inverse into 1 plus 2 into z inverse. Now we need to find the inverse z transform, which is x of n. Now we can easily go for the partial expansion method, that is x of z is equal to, I can write simply, see, no need to convert into z, that is taking a LCM. So keep it as it is, that is a by 1 minus z inverse plus b by 1 plus 2 into z inverse. But here variable is something like x, see 1 minus x means x is equal to z inverse. So to find a, I will find at z inverse is equal to directly, so 1 minus z inverse is nothing but 1 pole, so z in is equal to 1. So what is this value? 1 minus 1 by 3 into 1 by 1 plus 2 into 1. So 1 minus 1 by 3 is nothing but 2 by 3 by 1 plus 2, 3. So it is nothing but 2 by 9. Similarly, b, how to find? We need to substitute z inverse is equal to minus 1 by 2. See here. So if I make 1 plus 2 z inverse is equal to 0, 2 z inverse is equal to minus 1, z inverse is equal to minus 1 by 2. So here 1 minus 1 by 3 into minus 1 by 2 by 1 minus of minus 1 by 2. So what is this value? 1 plus 1 by 6 by 1 plus 1 by 2. So this will become 7 by 6 into 2 by 3. So what is this value? 2, 3. So it will become 7 by 9. Right? Now the x of z will become like this. Right here. A means we get 2 by 9 by 1 minus z inverse plus 7 by 9 by 1 plus 2 into z inverse. Right? Now to find the inverse z transform, we need to consider the ROC, which is mod z is greater than 2. So there are something like this. How many poles are there? Z inverse is equal to 1 means z is equal to 1. That is the 1 here. This is z inverse is equal to 1 by 2, that is minus z inverse, so z plus 2, that is which is minus 2 actually. So this will become at minus 2. See here. So see, I need a pole. So pole means 1 minus 1 by z, that is z minus 1 is equal to 0. So z will go to the numerator anyway. So z is equal to 1 pole. Similarly here 1 plus 2 by z is equal to 0. So z plus 2 equal to 0, z is equal to minus 2. 2 poles. Now if I make circles here, so 1 is at the 1 and the 2 is like this, right? Now the minus 2 means it's also 2. So he mentioned mod z is greater than 2. Now what is the common ROC? We need to make something like this. Mod z is greater than 2. That means mod z is less than 1, greater than 1 also should be there. Yes or no? Both are greater than 1. Then only we'll get common ROC here. So that means both are greater than 1. That means we should get in terms of a power n u of n. So if I take this x of n here, now see, this is looking like 1 by 1 minus a into z inverse. So and the ROC is mod z is greater than 1. For this case, mod z is greater than 1. So x of n will become, so this is mod z is greater than 1. So 2 by 9, a is nothing but 1. So 1 power n means 1 only into u of n. Plus this constant is 7 by 9 into, see here also mod z is greater than 2, right? So greater than means we should get a power n u of n. But see here, general form is 1 minus 1 by 1 minus a into z inverse. But a here is negative, then only it will become positive. So here it will become minus 2 power n u of n. This is the inverse z transform of this signal, the given z transform, right? Now we'll solve this question. So this question is given, the x of z is given, that is 1 plus z inverse by 1 plus 1 by 3 z inverse. So part A is assuming the ROC is greater than mod z is greater than 1 by 3, determine the values of x of 0, x of 1, x of 2. Similarly, assuming the ROC mod z is less than 1 by 3, determine the values of x of 0, x of minus 1, x of minus 2. Now to find the inverse z transform of this type of signals, we can go for the long division procedure, that is power series expansion method, or we can go with the normal the partial fraction approach also, but this is not a rational function. So first anyway we have to divide, right? So we will use the long division procedure to find easily the x of 0, x of 1, x of 2, right? So how to proceed? So first part A, that is mod z is greater than 1 by 3. That means the division we should take as it is. That is 1 by 1 plus 1 by 3 z inverse, the 1 plus z inverse. So to cancel one time. So 1 plus 1 by 3 z inverse. So this will become minus minus. So 1 minus 1 by 3. So 2 by 3 z inverse. So again to cancel 2 by 3 plus 2 by 3 z inverse. So 2 by 3 z inverse plus 2 by 9 z inverse 2, right? So minus minus. So again it will be minus 2 by 9 z inverse 2, right? So again to cancel it will become minus 2 by 9 z inverse 2. So minus 2 by 9 z inverse 2 minus 2 by 27 z inverse 3. So it will be cancelled. This will become plus. Now see, the question he asked only 0, 1 and 2. So x of z now will become 1 plus 2 by 3 z inverse minus 2 by 9 z inverse 2 and so on. But we don't require this one because in the question itself he asked 0, 1, 2. That means up to second order, that is fine. Now if I take the inverse z transform, this will become x of n. 1 means the delta n plus z power 1, z power minus 1 means 2 by 3 delta n minus 1. Z power minus 2 means 2 by 9 delta n minus 2 and so on. Now what is x of 0 value? Now what is x of 0 value? What is the amplitude of this first one? 1. Now x of 1 means this one, which is 2 by 3. Similarly x of 2 is minus 2 by 9. Now we will solve part B. So where the ROC is mod z is less than 1 by 3 and this is the x of z. So whenever we are going for less than 1 by 3, the ROC is less than some value, we have to divide with the, we need to take the suppose this is the denominator. So we have taken as it is in the part A. In part B we have to do the opposite. So in the negative powers will come first, that is 1 by 3 z inverse will come first, then the constant will come next. So highest negative powers to the constants, right? Similarly, this also will be same, Z inverse plus 1, right? Now if I try to multiply, then we will get the whatever the quotient here, that is the Z transform will take, then we will take the inverse. Now we should cancel Z inverse, so we have to multiply with 3 here. So 3 into 3 will be 1, so it will be Z inverse plus 3 here. So minus minus. So 1 minus 3 means minus 2. Again, to cancel out minus 2, we have to multiply with minus. So 3 we should cancel and we should get 2. So if I multiply with 6, so 3 2s are 6, so minus 2 will come into, to cancel out Z inverse, so we have to multiply with Z. So Z into Z inverse is 1, 3 2s are 6, so minus 2. So minus 2 minus 6Z. So this will become plus, this is also will become plus, then 6Z will be there. Again, to cancel out 6Z, what we need to do, multiply with positive. So we should get 6, so 3 6s are 18, so we need to multiply with 18 and we should get Z here. So again, but it is Z inverse, we have to multiply with Z square. So what will get, 6Z plus 18 Z square. So what will get, this is minus minus, so minus 18 Z square. But we don't require the further because he asked only 0 1 and 2, right? So this is here he asked about 0 minus 1 minus 2, so up to here it's fine. So if I write x of Z, so what is this, 3 minus 6Z plus 18Z square and so on, but we don't require that one. Now if I take the inverse Z transform x of n, so there is a constant, so we'll get 3 into delta n minus 6 into Z power 1, so delta n plus 1 plus 18 delta n plus 2 and so on. Now from this, so what are the values? So this will become x equal to n equal to 0. So x of 0 will become 3. N plus 1 means the advanced version, so it will be left shifted. So that is x of minus 1 is nothing but minus 6. Now this is advanced by 2 units, so del x of minus 2 is nothing but positive 18, right? So plus 18. So this is about this problem, right? Now if you observe, whenever the ROC mod Z is greater than 1 by 3 or mod Z is greater than, so we'll get the increasing negative powers, yes or no? But whenever the ROC is less than 1 by 3, so we'll have positive powers in the incrementing order, right? So 0, then Z power 0, 1, 2 and so on. So that we can now conclude from these two examples, right? Next we will solve this question. So this question is, determine the number of zeros in the finite Z plane. So remember, finite Z plane and the number of zeros at infinity, that we need to find. Now I told you, when the denominator is equal to 0, we'll get poles. So poles means denominator should be 0, make equal to 0, or the fractions in the denominator. The zeros means the numerator fractions or numerator should make equal to 0. Now if I make the fractions like this, Z inverse is equal to 0. So what is this meaning? Z inverse is equal to 0 means Z is equal to infinity. That means one pole at infinity. One more is 1 minus 1 by 2 Z inverse equal to 0. 1 minus 1 by 2 Z inverse equal to 0. So what is this meaning? So it will become 2Z minus 1 equal to 0. Z is equal to 1 by 2. Now if I make in Z plane something like this, so Z is equal to 1 by 2 means somewhere here, and Z is equal to infinity means now at the infinity. So one at now finite Z plane, one at infinity. So that is about this one. So the second one is, now again numerator becomes 0. That means 1 minus Z inverse equal to 0 means, so it's nothing but Z is equal to 1. So 1 by Z, so Z minus 1 equal to 0. Similarly 1 minus 2 Z inverse means what? So this will become Z minus 2 equal to 0, Z is equal to 2. So both 1 and 2 are finite Z plane. So in the finite Z plane, two zeros are there, and at the infinity no zero is there. Third one, So to make 0, so z minus 2 equal to 0. So z minus 2 means 1 by z square equal to 0. That means z is equal to plus or minus infinity. That means 2 zeros at the infinity. Yes or no? So that is 2 zeros at the infinity. And for this one, 1 minus z inverse equal to 0 means z is equal to 1. So 2 zeros at infinity, so plus or minus infinity, and 1 0 at finite z plane, right? So this is how to find the zeros. And they may ask about the poles also. So these two are finite poles, finite poles, finite poles, right? Two finite poles are there. So that is about this question. Next we will solve this question. So x of z is given, we need to find the inverse z transform. So when the quadratic expression is given, so first we need to find the roots of this quadratic expression. Now whenever there is a fractions, so sometimes it is difficult, sometimes it's very easy. That comes by the practice. Now if you don't know anything, it's very simple. That is, first take LCM. So make it as in terms of z square, z, etc. So from this I can make it as 8z square, 3 by 8z square. So I will write like this: 5 by 4z plus 3 by 8z square. Now if I take 8z square common, this will come to the numerator. So 8z square means 1 means 8z square plus 4z is gone. So what we will get? 2z. So 2z into 5, 10z plus this is a constant, we will get 3. Right? So this is the x of z now. Now to make fractions, now it's easy. See, if I multiply, we should get 8 3s are 24, and if we add 10. So what is 6 4s? 6 4s are 24. 6 plus 4 is 10. So this will become 8z square by 8z square plus 4z plus 6z plus 3. If calc is there, it's very easy to find the what you call this roots. But in the GATE exam now, we are not allowed to take the calc. So practice like this. Now see, so from this 2, if I take 4z common, so this will become 2z plus 1, right? Into plus, if I take 3 common in this, so it will get 2z plus 1. Now see, we got the fractions. So I'll write here. So x of z is equal to 8 into z square by 4z plus 3 into 2z plus 1. Now if I multiply, we'll get same as this. Now we should not have in this form. So what we'll do, we will again take some LCM. So z means we'll now take z here common. So what we do is, if I take 4z common in this 8z square by, if I take 4z from this, so it will become 1 plus 3 by 4 z inverse. Similarly from this, if I take 2z common, so what will get? 1 plus 1 by 2 z inverse. Now see, 4z, 2z, 8z square will be cancelled. Now see, x of z now will become 1 by 1 plus 3 by 4 z inverse into 1 plus 1 by 2 z inverse. Now if you multiply also, you will get same as it is, right? That you can verify. Now how to proceed further? Now it's very simple. Now we're using the only partial fractions. So this will become a by 1 plus 3 by 4 z inverse plus b by 1 plus 1 by 2 z inverse. This is the x of z. Now how to find a value? So a is equal to, z inverse is equal to minus 4 by 3. See, if I make it is equal to 0, so this will become minus 4 by 3. So 1 by 1 plus 1 by 2 into minus 4 by 3, you need to multiply. So this will become 2 2's. So 1 by 1 minus 2 by 3. So this is become 1 minus 2 by 3 means 1 by 3. So a will become 1 by 1 by 3 means 3. Right? Next to find b. So b is equal to b is equal to, at z inverse is equal to 2, we need to find b. So 1 by 1 plus 3 by 4 into 2. So what is this value? So 2 2's. So it will become 2 by 5. Yes or no? Right. So now the x of z will become, a means 3, so 3 by 1 plus 3 by 4 z inverse plus 2 by 5 1 plus 1 by 2 z inverse. Now we are having two different x of z's here, x1 of z, x2 of z. Now we'll have three possible ROCs here. So one is mod z, see both are positive only, so actually it should be minus, right? So we can have one is mod of 3 by 4 and one is mod z is less than 3 by 4. Similarly here also mod z is less than 1 by 2 and mod z is greater than 1 by 2. But the common ROC will have only three possible conditions. So now first case we have to consider is, suppose the case 1. So in case 1 we'll have assume both are greater than 1 by 2 as well as 3 by 4. So 3 by 4 means 0.75, 1 by 2 means 0.5. So what is the common ROC will become 3 by 4. So for this one, what is x of n? So both are greater means in terms of a power n into u of n. So 3 into, it should be minus but we are having positive, so it will become minus 3 by 4 power n u of n plus 2 by 5 into, here also minus 1 by 2 power n u of n. This is the first case. The second case, so what is this? 1 is greater than and 1 should be less than. So always the smaller one is always greater than. So the case 2, mod z is greater than 1 by 2 but mod z is less than 3 by 4. Right? This is the common ROC, something like this. This is 0.5 and this is 0.75 and these are the circles, right? Now the case 1 means greater, less than. So this is the common ROC. That is just two serial sequence will get. So what is x of n now? So 1 is some, okay, here, see here. So this 3 by 4 is less than but 1 by 2 is greater. So we'll get a power n u of n, this one. So 2 by 5 is the constant into minus 1 by 2 power n u of n, one term. Now see here we are getting minus, so we are not getting minus here, right? So it is a positive only. So it should be in the form of z by z minus a, right? So what will get? Minus. So minus is, so it's a positive, so we should get minus, and 3 into minus 3 by 4 whole power n u of minus n minus 1. Right? This is the second one. So what is the case 3? Both are less than 1. So less than 1 by 2, less than 3 by 4. So what is the common ROC? Mod z is less than 1 by 2. So x of n will become both are less than. So you see here both are positive, so we'll get both are negative. Minus 3 minus of 3 by 4 whole power n u of minus n minus 1. Second one also something like this, 2 by 5 minus 1 by 2 power n u of minus n minus 1. Now what is the other, the case 4 which is doesn't exist is, one is like this, mod z is less than 1 by 2 and mod z is greater than 3 by 4, which is not any common ROC will not declare in this, so we cannot find the x of n, right? Now we'll see one more question. So this is somewhat different. So x of z is given, so 1 minus 1 by 4 z inverse 2 by 1 plus 1 by 4 z inverse 2 and so on. How many different ROCs could respond to x of z? So we need to find the different ROCs. That is, now first we need to go for the quadratic expressions and roots. So that is 1 by 4 z inverse 2 by, this will become 1 plus 1 by 4 z inverse 2 into 1 plus 5 by 4 z inverse plus 3 by 8 z inverse 2. Now to find the ROCs, first we need to find the fractions. Just now we found for this one, so that is, and remember always whenever we are going for the partial fraction approach, the denominator order should be greater than the numerator order, right? Even it is a negative or positive. So it is okay, so it's a rational function. So 1 minus 1 by 4 z inverse 2. So this one we have written like this, 1 plus 3 by 4 z inverse into 1 plus 1 by 2 Z inverse. See, so 1 into 1 1, 1 plus 1 by 2 plus 3 by 4, so it's nothing but 5 by 4 Z inverse plus 3 by 4 into 1 by 2, 3 by 8 Z inverse 2. Now how can I write this one? So a square minus b square, right? So a square means 1, so a minus b, so 1 minus 1 by 4 Z inverse. One more is 1, see, so square means you should be 1 minus 1 by 2, 1 plus 1 by 2 Z inverse. Now will I get same? 1 a minus b into a plus b, so a square means 1 minus b square, so minus b square means, so minus Z inverse 2 by 4, so it is, but it is coming positive, right? But we are getting negative. So how to get? If I add some I here, suppose I, so we have to go for the complex. So 1 minus j by 2 into 1 plus j by 2, so a square means 1 only, minus b square, so b square means minus j by 2 Z inverse square, so j square means again minus of minus 1, so it will become plus, and this will become Z inverse 2. Now see, now this is the fractions here. Now if I write clearly, 1 minus 1 by 4 Z inverse 2 by 1 minus j by 2 Z inverse into 1 plus j by 2 Z inverse into 1 plus 3 by 4 Z inverse into 1 plus 1 by 2 Z inverse. This is the x object. Now to find the possible ROCs, so what we need to make, so for each fraction we have to take either less than or greater than. So if I take first one, so that is j by 2 Z inverse, so either less than 1 or greater than 1, yes or no? So see here, so that means, so mod of I means it will be 1, so 1 by 2 is less than Z, or mod Z is greater than 1 by 2. Similarly, for 1 plus j by 2 Z inverse will get same, because mod of minus 1 by 2 or mod of j by 2 is very same, right? So for these two factors, so we'll get same as mod Z is greater than 1 by 2, or one more is mod Z is less than 1 by 2, right? Similarly, plus this last fraction is also same, 1 plus 1 by 2 Z inverse means we'll get mod Z is greater than 1 by 2, mod Z is less than 1 by 2. Now if you see first 1 2 3, for 3 fractions we'll get 2 possible ROCs, that is mod Z is less than 1 by 2, mod Z is greater than 1 by 2. The one more is 1 plus 3 by 4 Z inverse. So for this case we'll get one is mod Z is greater than minus 3 by 4 or mod of 3 by 4 and less than 3 by 4. So from this all factors will have the possible ROC combinations. ROC combinations are same as the previous example, that is mod Z is greater than 1 by 2, mod Z is less than 1 by 2. So mod Z is greater than 3 by 4, mod Z is less than 3 by 4. Now what are the possible combinations that x of Z responds? That is always 3 possible cases. 3 possible cases the x of Z responds. Reason is we have seen in the previous example, that is the first case is both are greater than 1 by 2, 3 by 4. Second one is 1 by 2 greater than, 1 is less than 3 by 4. The third case was both are less than, that is mod Z is less than 1 by 2, mod Z is less than 3 by 4. The fourth case is doesn't exist because there should not be any common ROC, that is less than 1 by 2 greater than 3 by 4, which is a not acceptable case. So how many possible combinations? Only 3 possible combination of ROCs the x of Z responds. So that is about this problem, right? So I solved some problems, so you do on your own the remaining from the textbooks, right? If you are getting any doubt, so post a comment, we can discuss, right? So in the next lecture we'll see the properties of the Z transform, right?